All right, so the last thing that's going to be somewhat difficult is going to be the word problems. So on the Edpuzzle assignment in Crusader Connect, I went ahead and attached the word problems. So if you want to print it out, perfect. If not, don't worry about it. You can just write the problems down or just write the work down on your notes. I don't really care. Okay, whatever helps you learn this. I know it looks like a lot. There are 3 topics worth of word problems, and I want to go through each one, and there's little tweaks with each one. So the first one we'll actually solve, and then the second one we'll just set it up, okay? It's not too bad, but so just so you can kind of see each one slightly different, it'll go really fast, trust me, they're not bad. Okay, so this first one, the sum of 2 numbers is 54. And the best way to do these word problems is read a sentence, and if you can translate it into an equation, put it into an equation. Okay, so we have 2 numbers here. Take 2 variables. I know the most common ones are x and y, so I'm just gonna do that. So the sum means to add, so I have x plus y equals 54. So I turned that sentence into an equation. Okay, the next one says the smaller number is 14 less than the larger number. So now I need to clarify, okay, which variable means what. So I'm going to say my smaller number is x, and I'm going to say my larger variable, or larger number is y, okay? And so the key word with word problems, by the way, is translates into equals. Is a key thing. The sum of 2 numbers, here's the sum, is 54. Okay, so we're going to say the smaller number, x, is 14 less than the larger number. So I'm going to take y minus 14, right? If you're 14 less than it, you subtract from it. Okay, if you did 14 minus y, you would be wrong. You would get the wrong answer. Okay, so make sure you're very careful with that less than. Okay, and technically when you do more than, it should be y plus 14, not 14 plus y. It doesn't matter with addition because the order of addition doesn't matter, but subtraction is very important. Okay, so make sure you write it correctly. All right, and so now we want to solve, and so this is the one case you'd probably use substitution. If you want to do elimination, it's fine, just subtract the y over and eliminate. I just love substitution. I think it's way more fun. And so I have an x equals, that's why I know I want to do substitution, because I have a variable equals something. So I'm going to substitute this guy in for x. Okay, and so what I get is y minus 14 plus y equals 54. So I'll add my 14 over, and y plus y is 2y, and that makes 58. Divide by 2, and 58 divided by 2 is 29. So I know my y value is 29, okay? And so I'm just going to plug that in to find x. So x equals 29 minus 14, and so x is equal to 15. And what did I do wrong? Because that's not coming out right. Oh, sorry, this should be 68. Whoopsie. That's what I did wrong. Okay, so how I knew I did it wrong is I added those 2 together, and we know they should equal 54. So that's why. So 59 plus 14 is, holy cow, I'm struggling today, is 68, and divide that by 2, so y is 34. I'm going to just erase that. So x equals 34 minus 14, and so that comes out to 20. Okay, and so the way to check your work, 34 plus 20 should equal 54, and it does. Okay, and so you'd write it as a point. Actually, I think they'd say you do smaller number, and you would put 20, and larger number, you would put 34, and you'd be good. So that's how you do that one. Okay, this next one, it's in the same topic. I just want to show you that it's not always going to be, oh, the sum of 2 numbers or the difference of 2 numbers. Some of it will actually be like a word problem. Okay, so the washer and dryer cost a total of $1,064. So change that into a sentence. So W plus D equals 1065. Okay, and then the cost of the washer is, okay, so that means W, washer, and then is translates into equals. 2 times, so that'd be 2x, 2 times, sorry, not 2x, 2 times, so 2 multiplied by the cost of the dryer. So I just put in a D there. And then this all I want you to set it up. If you want to solve this, you plug 2D in for W and solve for D, then plug it in to get W. All right, so hopefully that's not too bad. These shouldn't be terrible. This next one's a little bit more complicated, but it's not too bad. And so every type of problem will look really, really similar to this for this next topic. Okay, and so what we have and what you'd always probably want to do is just set up a chart. Okay, and it'll come pretty naturally. So she has 2 solo workout plans that she offers her clients. There's plan A and we have plan B. Okay, and so it will be like walnuts and cashews, or it will be a washer and a dryer, or it will be math class and science class. Like it'll be 2 entities essentially. All right, and so each client does either one or the other. You're never gonna do both, okay? And so on Monday, we had, there were 9 clients who did plan A, and we had 7 who did plan B, okay? On Tuesday, there were 3 clients that did plan A, and 5 who did plan B, okay? And then Amy trained her Monday clients, and so we're gonna do a total here. This was 12 hours, and our Tuesday clients for 6 hours. And then we wanna know is how long do they last? All right, and hopefully it's pretty obvious the total, right? That's usually where you put an equal sign, okay? And so you could just do plan A, 3A, and just do the B's there, okay? And now you have an equation. So you know 9 times however long the plan A workout is, we get you that, plus 7 times however long the plan B, we add those together, and the total is 12 hours. Okay, and then we got a 3A plus a 5B equals 6. All right, and so I want to solve this equation, and so this one I'm going to solve through elimination because my A's, B's, and constants are all lined up. Okay, and so I'm looking, I don't have a positive or a negative, but I do notice right here, 3 is a multiple of 9. 5 and 7, though not a big number, they're not multiples of each other. So I'm going to do the least amount of work, and I'm going to multiply this guy by a -3. And the reason is because you always want one positive and you want one negative, okay? So what that is going to get me, I'm going to copy down the first one. And so I have 9A plus 7B equals 12. And then I will get a negative 9A minus 15B equals a negative 18. And so all you want to do then is just add those 2 guys together. Okay, your A's make 0. 7 minus 15 is a negative 8B, and 12 minus 18 is a negative 6. And so to solve for B, you divide by negative 8. And so you have 6 over 8, which we know is 3/4, or 0.75. So what I know is workout B is 3/4 of an hour, or 0.75 of an hour. So we'd say plan B is 0.75 hours. Okay? And then how to find plan A, you just plug plan B into that and solve for A. And so I'm going to plug, let's see. Actually, neither one looks super good because 5 and 7 don't reduce out with 3/4. So let's just plug it into there because it's smaller. So 3A plus 5 times 0.75 equals 6. Okay, so 3A, 5 times 0.75 is plus 3.75 equals 6. 6 minus that answer, whoops. So I have 3A equals 2.25. And divide that by 3, and A equals 0.75. Well, that worked out. So they end up being equal. That is pretty rare, I'm going to be honest with you. That probably won't happen most times, okay? And you can always check your work by plugging it back in. So if I just do 9 times 0.75 and 7 times 0.75, and I add those 2 together, so 6.75 plus 5.25, it should equal 12. And it did. And same thing if you plug into the next one, that's how you check your work. All right, so it'll be essentially the same for everyone on that topic. All right, I think making the chart really helps you just translate it straight into that equation and do elimination. All right, back of this, and I'm gonna do a different one so it doesn't show through as much. Okay, these ones aren't too bad. This one, you'll have an A and a B value. All right, and so what we have is Raina will rent the car for the weekend. That's a sentence, but there's no math in that, so I'm not going to put it into the equation. Okay, she can choose one of two plans. Once again, not an equation, but I do know I have two plans. Okay, so the first plan has an initial fee of $40 and costs an additional $40 per mile. So I'm going to just write here first plan, okay? And so my cost is equal to $40 plus 0.40 per mile. And I'm just going to do M for miles, okay? And then the second plan very easily has no initial fee, so my cost is equal to, but it costs 0.90 per mile. All right, and so that's how I translated those sentences into equations. All right, and if I'm noticing here, they're both C equals, which makes life easy, because if they're both equal to C, then I can just set these guys equal, or essentially what you're doing is you're substituting this right in there. Okay, and so you'll have 0.90 miles equals 40 plus 0.40 miles. Okay, and so we want to, for what amount of driving do the two plans cost the same? Essentially what that means is where's the solution of those two guys? Okay, and I use the system or the method of substitution, and now just solve, okay, for the amount of driving, the amount of miles. So I'm going to subtract 0.4. Okay, and so we get 0.5 equals 40, so divide by 0.5. Okay, and I believe that will turn out to be 80. So for 80 miles, do the plans cost the same? And then what we want is, what is that cost? We'll just plug it in, it doesn't matter. I'm going to plug it into this one because it's just less math, so 0.9 times 80. And that will equal 72. But if you plug it into the other one and you do 0.4 times 80, and you add, and then you add the 40 to it, it does come out to be 72. Okay, so that's how those ones work. It'll be a cost equals, and you just set them equal to each other and solve. That's essentially substitution. You could do elimination. You would just need to have like a 0 plus here to line that up with that constant. Yeah. All right, so we're gonna just set this one up because it's once again just slightly different, but I just want you to see different things that it'll look like. Okay, 2 pools are being filled, so I know I have 2 pools. The first pool contains 1,600 liters of water, and the second pool contains this. Okay, so what I'm going to have is our total liters. Oops. And for the first pool, that's 1,600. Okay, and total liters. And for the second one, that's 1,195. Okay. The water is being added to the first pool at a rate of 21.5 liters per minute. So I'm going to add 21.5 per, and now M is going to stand for minute. Okay, and the second one, it is adding 32.75 per minute. Okay, and so this is what you would do to solve. Once again, they're both equal to total liters, and they'll ask, when do they cost the same? Or when will they have the same amount of water, and how much water will it be? Will essentially be the question. So you'd set them equal to each other and then solve. Okay, hopefully that makes sense, and that's all you have for 8.1.